Section 7.2, you must work on problems number 1 to 36. This is volumes by solids of revolution. When we rotate an area, it can create an object. And when we slice that object, we can get either a disc or a washer. The only difference, the disc is solid, the washer has a hole in the middle. Here's an example of a disc. If I have the function y equals square root of x, I get this curve. Now imagine that I'm going to rotate the area under the curve over the x-axis. This little symbol is x-axis. When I rotate this, I get this solid. Now, slicing the solid is the critical thing because we cannot slice it this way. We must always slice the solid in such a way that each slice makes a disc. That's why it's called a disc. Therefore, the slice has to be this way, and therefore, it's dx. Now, if I take the same function, y equals square root of x, this curve, and I rotate it over the y-axis, such a rotation is going to create this solid. And remember, we must always slice the solid such that each slice is a circle. So now the only way to slice it is this way, and therefore it's dy. However, when I slice it this way, I get a hole in the center because the curve is passing here and then over there. Therefore, the slice is going to have this hole because we rotated this solid that way, and you can clearly see that there is a hole here. There's nothing here. Okay, so it's going to make a washer. This is a washer. What is the big R? Well, the big R is simply the outer line of this washer, which is this part. Okay, and the little r is the inner line of this washer, which is that part. Now, here's an example from the book. This is problem number 6 in section 7.2. It's not an example, it's a problem. So, we have this equation. You must be able to determine what equation is it. Well, the line is straight, it's coming down, it's passing at 1 on the top. Therefore, this is y equals minus x plus the 1, the intercept. If we rotate over the x-axis, the solid is going to look like this, and we slice it over the x in order to get a circle. And the circle has a little radius, little r. The question you must ask is, what is the function that creates the circle line? Well, how do I know? Well, just look here. When you rotate, it's this line that is the outer line of the circle. Therefore, this function is what's making the outer line of the circle. Now, the integration to find the volume is simply adding all the circles. If you add all the circles in this drawing, the tiny ones and the slightly larger and larger and larger to the last one, which is the largest, you add them all, you have the volume. Therefore, you're adding areas of a circle. So we go back to geometry to see that the area of a circle equals pi r squared. Well, but my r is a function. Therefore, I square the function. So the area of everything is simply the summation of all these areas, which is pi function squared. The summation is the integration sign. The r squared now, the r is a function, so I put the function into the r and integrate from 0 to 1. This is the domain of x where the volume of interest is 0 to 1, 0 to 1. So this setup then is the setup to find the volume of this rotation over x. Note that I have a binomial, so I need to expand this binomial. The binomial expansion is simple. We know how to expand a binomial. Square the first times the second. Minus x times 1 is minus x, times 2, minus 2x, plus square the second, which is square the number 1, you get number 1. Therefore, we're talking about integrating pi 0 to 1, x squared minus 2x plus 1 dx. That integration gives x cubed over 3 minus x squared plus 1, and we integrate from 0 to 1. That will give 1/3 minus 1 plus 1. These two cancel out. And the volume is 1/3 pi, don't forget the pi, units cubic, because it's volume. So this is the answer. Let's see now how this works if we are to rotate over y. Note that when we rotate over y, we take this area under the curve and spin it all around and keep spinning that all around. It creates this solid. The solid is going to be a disc, not a washer. It has no hole in it. But if I continue to cut it over x, I do not get a circle. I must always get a circle. Therefore, the only way to get circles is to cut it or slice it over y, and that makes dy. So I'm also going to have a little r here, except that the slices now are piled up this way. Note that I must integrate over y, therefore I have to switch the function to y's, meaning it has to be x equals something. How do I do that? Well, here's the function. Subtract 1 from both sides, I get this. Now, I have minus x, I want plus x. Multiply the whole thing by minus 1. That makes the x positive and makes the y negative and makes the 1 positive, and we get this new function to integrate. So, back to our integral setup. The volume is pi 0 to 1, because the y here goes from 0 to 1. It still goes from 0 to 1. In some function, this is not the same as the x. But here, 0 to 1. So here is our r squared. Our r is a function, okay? It is this line that is going around and therefore making the edges of this circle, which is the same circle. We expand this binomial, we get this expansion, dy. When we integrate this piece, we're getting a y for here, a minus y squared, because the 2 cancels with the dividing 2, plus y cubed over 1/3, which is this. Plugging the 0 and the 1, we also get the volume is 1/3 pi units cubic. So, in this case, the volume of integration over the x and over the y are going to be the same. They're not always the same, but in this case they are, because of the line, of the straight line. If we had a curve, the volumes could be different, okay? So examples A and B, both are discs, not washers, both yield the same volume. Now, Sometimes, if you rotate over X or over Y, it becomes a washer. And the volumes are not necessarily the same. So, back again, make sure you review these videos, go to your book, and solve or work on problems 1 to 36. The next video is going to be both washers. The only thing that could stop you from doing these integrations here is the algebra, because if you can't expand the binomial, you can't solve this. And it's not always binomial. There will be other algebraic things to be done here before you can integrate. I hope you take your time reviewing this, working on problems 1 to 36, and prepare yourself for homework, quizzes, and exams. And have a good day.